Hello students, welcome to section 20. In this section we'll be covering a few more questions, or rather just one question from solved examples and some of the questions from practice set 1.5. So now here I have question example number 4 from page number 24. The question goes on as a certain amount is equally distributed among certain number of students. Each would get rupees 2 less if 10 students were more, and each would get 6 more if 15 students were less. Find the number of students and the amount distributed. Now again, as I said earlier, whenever it comes to word problems, you need to read one statement at a time. That will give you the required information to solve the question in a much simpler way. So now let's start. A certain amount is equally. So now the key word here is equally. So what this means is that each student is going to get the same amount. That means there is an equal distribution, and therefore I can assume that the amount distributed between all the students can be same. So in this case, let's say the amount each student gets is equals to x. So in this case, I'm assuming amount that each student gets is x. And remember, the total amount is distributed in the number of students, but this amount here, the x amount, is the amount that one student gets. This is very important, and we'll see in the ahead why it is so. Now, going ahead is distributed among a certain number of students. So now we know what we have to take as our second unknown variable. So let number of students be equal to y. Now we know that certain amount is equally distributed among certain number of students. That means the total amount of money that there is x into y, that is amount for one student into number of students. So this is equals to my total amount. Now let's go ahead and read the statement after that. Each student, each would means each student would get rupees 2 less. Less means there is subtraction involved if 10 students were more. Now here the statement says that there are y students, and as it says, if 10 students are more, each student gets rupees 2 less. So my number goes to y, from y to y plus 10, and my amount per student goes from x to rupees 2 less. That means now my new amount in this case is x minus 2. But remember, the total amount has not changed. Therefore, y plus 10 into x minus 2 is still equals to xy, which is my total amount in in this case. So now as we go on solving this question, we'll get, I'll write the equation once again. This is y plus 10 into x minus 2 is equals to xy. This implies xy plus 10x minus 2y minus 20 is equals to xy. Now xy cancels, so here I am left with 10x minus 2y minus 20 is equals to 0. This is my equation number 1. Now for my second case, the statement says, and each would get rupees 6 more if 15 students were less. That means in this case, now it says that from y, the number of students y, the number of students goes to y minus 15. 15 students less means there is subtraction involved, which we have accounted for. And now for the amount, each student would get rupees 6 more when 15 students are less. So from x we go to x, there is 6 rupees, and the statement says more, that means there has to be an addition. So now once I get this, again my total amount has not changed, so this implies y minus 15 into x plus 6 is equals to xy. Again, once I open the bracket, I'll get xy minus 15x plus 6y minus 90 is equals to xy. Xy cancels, so I am left with minus 15x plus 6y minus 90 is equals to 0. This is my equation number 2. Now writing both the equations, so I have 10x minus 2y minus 20 is equals to 0. This is equation number 1, and I have minus 15x plus 6y minus 90 is equals to 0. This is my equation number 2. Now I'll be using elimination method. So equation number 1 times 3 gives me 30x minus 6y minus 60 is equals to 0. This is my equation number 3. Now adding equation 3 and 2, I get 30x minus 6y minus 60 is equals to 0 plus minus 15x plus 6y minus 90 is equals to 0. Now the plus sign does not change any sign inside, so we'll leave it like that. 30 minus 15 is plus 15x, minus 6y plus 6y is 0, and this is minus 150, which is equals to 0. So now minus 150 goes to the right hand side, so I have 15x is equals to 150, which implies x is equals to 10 rupees. Now once I get x equals to 10 rupees, I'll put the value in the next equation. Put x is equals to 10 in equation 1. So here I have 10 times x minus 2y minus 20 is equals to 0. 10 into 10 minus 2y minus 20 is equals to 0. Then I have 100 minus 20 is equals to 2y, which implies 2y is equals to 80, and therefore y is equals to 40. So I have x as 10 rupees and y, which is the number of students, is equals to 40. So here I have my answer. You can check the solution from the textbook. Make sure that whenever you solve this solved example in your copies, you use those methods that are very hard for you or you find difficulties trying or getting answers. So for example, let's say somebody faces problem in Kramer's rule. Try to solve this same question using Kramer's rule. That will help you practice all the problems. Now before we move on, there's few things that I need you to remind. From now on, whichever word problems we'll try, I'll help you out in how to think to get the equations. Once we get the equations, it is now your responsibility to solve those equations. I will not be solving those equations further because we have practiced linear equations 4 exercises trying to solve all of those questions. So by now you should be able to solve all the equations. Now we are going to focus on how to think to solve questions instead of just solving them. So moving on to practice set. Now example number 5 is quite a complicated example. We will do this once the school reopens or once this chapter is over, whichever comes first. Now for practice set 1.5, I'll be doing 2 questions in this section. Remember, I'm just going to help out with the equations. You have to solve those questions for yourselves. Now here I have practice set 1.5. I'll start off with question number 1. It says that two numbers differ by 9. So as always, I'll say let the smaller number be x. So this implies, and let the larger number be I'll say that the larger number is y. Now, the first statement says that the two numbers differ by 3. So therefore, if my larger number is y, that means y minus x is equals to 3. So this is my equation number 1. Now, my second equation is the sum of twice the smaller number. That means I have twice the smaller number. Here the smaller number is x. So 2 times x, and the question says the sum. So 2 times x plus and thrice the greater number. That means 3 times the greater number. This value is equals to 19. So this is my equation number 2. We'll go over it once again. As the question says, sum means there's an addition sign, so I have an addition sign here. Then the second statement, the second information that they say is sum, twice the smaller number. So we have 2 times x, and then it says twice the smaller number and thrice the greater number. So we have 3 times y over here. This sum is equals to 19. So my equation number 1 is y minus x is equals to 3, and equation number 2 is 2x plus 3y is equals to 19. Now, once I get this, you can all try and solve this pair of equation by whichever method you want to. Make sure you try out with the method you find the most difficult. Now moving on, I'm going to solve question number 3. So in question number 3, I have the sum of father's age and twice the age of his son is 70. Now, the first statement itself gives us some information, so we need to start assigning values. So let's say the father's age is x, or rather we need to be correct in our grammar as well because we are studying English as well. So let the father's age be x, and I'm going to say that the son's age is y. Now once I have this, the first statement says the sum of father's age. Now in the very first statement we have the term sum. Sum means there is an addition sign. Sum of father's age, that means I have x plus twice the age of his son. 2 times the son's age is defined by y, so this is y, and this sum is total equal to 70. So this is my equation number 1. Now in the second statement, if we double the age of the father, that means now I'm going to say if 2x and add it to the age of his son, and we are adding 2 times the father's age to the age of son, so I'm adding, that means plus, and adding to the age of son, which is equals to y, this value becomes, now their sum is 95. So this is my equation number 2. So here I have 2 linear equations. Again, you all have to try this by yourself. Make sure you solve it out and find the answer. If you still aren't able to find the answer, just message me on the WhatsApp group and I will help you out. This section ends here, and in the next section we'll be moving to homeworks regarding practice at 1.5 and some new concepts for linear equations from your problem set 1 or the miscellaneous exercise, that is from page number 27 to page number 29. Thank you.